So for regression model, say suppose I take a weather data. Okay, I'll go to import. And here I'll type weather. Yeah, this data I'm going to take. So here we have some missing data also, like column 9 is entirely missing, and in fifth row and sorry, row 9 is entirely missing, and fifth row and 14th row we have missing data in rainfall. Okay, so say suppose I want a regression model that can predict the temperature at 3 p.m. Okay, and in this database I have lot of data: minimum temperature, maximum temperature, rainfall, evaporation, sunshine, wind gust, wind speed at different parameters, say 9 a.m., wind speed at 3 p.m. Then I have humidity. So different data we have, and I don't know, like say suppose I'm from totally a different background, okay, and I don't understand like what is the effect of each parameter on the temperature at 3 p.m. Okay, so how can I able to know this thing, like which feature will contribute more? Okay, so for that what I will do, say suppose I select column A. So here's what is my objective. My objective is to check or predict or build a model which can predict the temperature at 3 p.m. So that is my objective. So for this objective, I want to select some feature which can contribute. Okay, so minimum temperature I take, maximum temperature of that day I take, and then uh, rainfall I don't think, evaporation, sunshine, yes, wind gust, okay, I don't know what, but I randomly select humidity at 9, humidity at 3 p.m., and cloud at 9 and cloud at 3. So suppose I take only these amount of limited feature out of the entire parent database, okay, and I put it into a variable called data and import this data into workspace. Now, so regression model with section breaker. Okay, okay, so first what I will do, I'll import the data. Say it is with data only. Yeah, it is with data. So I'll run this section first, and I can see the entire data: max temperature, minimum temperature, sunshine, wind gust, whatever we have selected, that is there. But this data contains some empty row also, which I want to remove. Okay, so I'll use the command in order to remove any empty row using not is missing function. I'll copy this one and update the code. Okay, so I'll use this function in order to remove the data, and then I'll run it, and now it will remove the data. So ninth number of row is eliminated, and now we have a table which is having all the data. Okay, so here. Now my data is ready, and now I want to make a regression model. So for the regression model, first we will go to the toolbox, regression toolbox, not required. So I'll go to the app section, and here in machine learning toolbox or deep learning toolbox, I have a separate toolbox with regression learner. I'll click on it. So earlier in the case of classification, the efficiency was given by accuracy word, but here because we are dealing with regression and it has a particular number as an output, so here it will give efficiency in terms of RMSE, that is root mean square error, and the lowest value will be taken as the best solution. So I'll click on the plus symbol in order to include the table. So all my data is stored into a data table, and here at temperature at 3 p.m. it automatically able to take it for a output or response, and say I use by default 1 by 5 as a testing model and 4 by 5 as a training model, and I'll start the session. Okay, so this is just the scatter plot. So with the scatter plot also, it can give us a pretty good idea that whether or not it has an effect on the contribution of that feature. If the plot is having some negative or positive correlation, then it has some effect. But if it is quite scattered, then it won't have any effect. Say I take the minimum temperature, then I can see the data are quite arranged in somewhat, like if the temperature is also increasing, so does my response is also increasing. So I have a good positive correlation here. In max also I have a very good precision also as well as accuracy. And sunshine, I can see it is quite scattered, so I don't think it won't prove any or have an impact in the overall learning model. Okay, because the data is quite scattered throughout the space, so it has very poor correlation. Windgust 2 has a very poor correlation. Humidity, yeah, humidity at 3 p.m. has a negative correlation because I can see the all the data is going in like say negative slope. Humidity at 9, humidity at 3. 3 is like having more precision and accuracy compared to humidity at 9. Cloud do not contribute any because the data is quite scattered, and cloud at 3, 2. So now what I will do, I'll first take all the feature. Okay, so feature selection I can do with here, like just you have to click on feature, and here you can check and uncheck those feature which should be the part of our training model. Okay, so for the first, the beginning one, I'll take all feature. Okay, so that I want to know which training model will give me the best result. Okay, so I'll click on all and click on the train. It will start the parallel pool, and once the parallel pool start, it will do the training part on all the different training model present in Matlab, and it will give us the best training model which is suitable for our experiment or on this observation set of observations. So we'll wait for 2 minutes till the parallel pool opens.
So how do you select the best training model out of these?
Sir, we do not select. Actually, we give this task to Matlab, and what Matlab does, whatever training model we are having and present, it will train on all those training models, and it will give the efficiency in term of RMSE. So whichever is having the least RMS value, that Matlab will give you as a good result. Like this training model is performing best, so you can further optimize on this model only. Because in beginning nobody can tell because of the data type, like whatever we have, the pattern, maybe some other model can perform in that pattern of data very well. So that's why there is no such rule like which model will going to perform better. It's only after by testing we can say. We'll wait for 1 more minute. Now, soon this parallel processing will start on GPU. Okay, it started. So yeah, show fewer details. Parallel pull on local has been started. So as we have seen, like there are some data which have a very poor correlation. So we'll take a note of it, and later on, once this parallel pulls start training on it, next step, we will going to remove all those features and see whether or not we have any improvement in the overall model or not. So first one is the cloud at 3 p.m. Cloud at 3 p.m. Then yeah, have to wait. Post the code for SuperNet and AlexNet. Okay, sure. That's why I have coded everything in LiveScript. After the end of this session, I'll convert it into PDF and put that one into the WhatsApp group. It's not an issue. Yeah. Okay. So now our machine learning model is ready for the training part. And here Matlab like put everything, all types of model, and it is started the training model on GPU. So here 8 by 8 means we have total 8 feature and we are taking all the 8 feature for the training. So that's why it is giving 8 by 8 number. 1, 2, 3, 4, 5, 6. Okay. So this one linear regression gives 0.8 as a RMSE. So MATLAB will search for even lower. In SVM quadratic, we have even less, which is 0.766. So right now, up to here, we have SVM quadratic as the best model. Okay, yeah. So all this thing has been completed, and we come up with the best as SVM quadratic as the best training model. And now we will compare this thing, because once we did this analysis, now we don't require to run it over and over the entire this thing. So rather what we do now, we will only run on the SVM quadratic by deselecting those which are not having good correlation. So cloud at 3 p.m. do not have any good correlation. Cloud, I think 9 a.m. also do not have any good correlation. So this one also we will remove from the model. And humidity 3, it has a good correlation. Humidity 9 do not have any good correlation. So humidity at 9 we will going to remove. And wind gust, wind gust 2 do not have anything. So we're going to remove this thing. So because these are not participating or having any important feature, and rest everything else. So 4 feature we have to remove. This cloud at 3, cloud at 9, humidity at 9, and wind gust speed. So after removing these 4 features, okay, now we are left with only 4 feature. And now I want to run this 4 feature only on the quadratic SVM, because I've already tested out and I come to know that SVM quadratic is performing well. So I'll run only on the SVM quadratic. And now here it shows 4 by 8. Okay. And in this case, it gives 0.8 as RMSE, which is quite greater error compared to this one. So let's check with wind gust. If we include the wind gust also, then what is the effect? So a slight improvement in result is there if we add wind gust as a kind of a feature. From 8.83 it come to 0.79. Okay, what if I include cloud at 3 p.m.? Do it have any positive? Okay, yeah, it has very little effect, but yes, it has. So 0.77, and okay, and lastly it will come to 0.76 only. So uh, okay, so somehow these data have slight this thing improvement in the overall error accuracy. If we check the residual plot, then we can see like this is the error range we can get like once the model is created. And here we can note one thing, that the prediction of temperature at 3 p.m. okay, uh, it can have error of +2 degree, okay, but the maximum if we take account in the lower range, then the temperature can go below up to -5 degree in actual with respect to the predicted result. Okay, because the negative part, and this may be due to the cloud presence or due to the rain, because the temperature can decrease drastically, then it can increase with that respect. So we can have a higher error in the down and least error in the up. So yeah. So now once this model is created, okay, or let me check with other case also. Say suppose if I only take three parameter, that is maximum temperature, minimum temperature, sunshine, and this one. Do it has any positive effect on the overall prediction? No, because still, yeah, if I see at the residual plot, then I can see the error is quite converging, but just in some cases, like the error because of this outlier, which is going below -8, the overall RMSE comes to 0.96. But looking at the overall plot, I can see that if I consider only these three parameters, that is minimum temperature, maximum temperature, and sunshine, the error density is quite closer to the predicted or the neutral line, that is zero axis line, in comparison to the this one, where we have 7 feature out of 8. The error is quite scattered and having higher spatial distribution than compared to this one, in which we have taken 6, and we will compare with the best one also, in which we are having. Okay, so instead of RMSE, okay, like here we have a clear visual difference. Like if we take all the feature like unnecessary, we are taking wind gust and cloud at 3 and 9, which has no better improvement over the entire result. We can see the error distribution in the space. And if we compare this one with only just 3 feature like maximum, minimum, and sunshine, we can get a very close relationship. So we can take this model also, because this outlier which we are getting -8, it can be the reason that at this point maybe their rainfall has happened, due to which the temperature just dropped down to what it is predicted. Okay, but most of the time it is very close to the zero axis line. It is densely populated. So once that is done, I'll take a 1 minute break. Excuse me. Okay, I will continue now. So now I'll export this model, and as what we have seen in the classification model, same option here we have. Either we can go for a generate function or for an export model. So this time I just go for the export model in order to check the output. So I'll name it as a temperature model, temp model, and OK. So here on the workspace, we have our model ready, and it says that in order to use or check the output, we have to use this as a function, Control C. And now I'll use this one in my live script to check the output. Yeah, okay. 1 minute. It is like my system again is hanging. Okay, now it is fine. So this piece of code, I have to use it in order to predict the output. But yes, the data should be in tabular format. So first I have to create a table also containing all these values, and then I can see the output. So say I take uh, what I will do. So data is equal to this, and say so the row name I have sorry, the column name I have to keep it same as what we have used here. Okay, so that is the problem. So now what I will do, I'll create an Excel sheet only in order to deal with this problem and put the data as it is. Control A. Control A. Delete. I'll go to workspace, and from the data table variable, I'm going to copy the cell information. Or wait a minute, what I will do, I'll create a dummy data here using by loading the data value only. Say y is equal to data. So it will create a dummy variable in y also. And this y I'm going to edit by removing all the other information. Yeah, delete. And here only I can edit the value. Delete. Why it is not deleting? Okay. 80. Now I have to create a table only and open this one Excel sheet which is having the energy data, sorry, temperature data. Weather data. Okay, so from here, I'll remove all this data and create a duplicate copy of this table by changing some values. Say minimum temperature instead of 8, um, I put it 12. Okay, max temperature I put it 20, 29. Evaporation I keep it same. Sunshine say 7. Okay, wind speed I'll let give it same only. Another parameter also same. So here the output is 23.6. We want to see whether it is increased or not. Okay, by increasing the minimum and maximum temperature, like how much output now we will get. Okay, and because this should be my prediction, so I'll remove this column. This I have noted in a separate paper, that value, and this I'll save it file into with a different name. Save as, say, test CSV, test weather, with the name test weather. Yeah. Do you want to keep using the format? No. Weather CSV not required. Test weather is already saved. Yeah, saved. I don't require. Now I'll go to Matlab and say using import. I'll check. Not data analytics. It is an IT program, and here I have test weather. Yeah, this one. Okay. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so 8 feature I have selected there. So only 8 parameter only I have to pass, not the all parameter. So here also I have to make it selection. Like minimum temperature I have included, maximum temperature, and then I have included sunshine, wind gust, and after wind gust I have included humidity, that too at 9, 3 p.m. and cloud at 9 p.m. and cloud at 3 p.m. Okay, yeah. So this many data I'll import into a table, import data with a test weather variable name. Okay, so if I run this test weather and make a home, and here if I take test weather, then it contains all that data, and here we have one row as a name. So first we will remove this row using the same command which we have used in the live script editor. Control Z, yeah, Control C, and paste it here. So instead of test data, I'll write test weather. Control X, Control V, Control V, and Control V. Okay. So now it is ready, all the data set. Now I have to use this function in order to calculate the value. I'll use it here. Instead of T, I have to pass test weather. And in comparison to 23.6, we want to see whether the temperature increased or not. So it has increased. And now the output from this regression model is 27.662. Okay, so that is very obvious because we have increased the minimum and maximum temperature. So it is giving a good correlated result. Okay, so this way we can deal with regression model also, like how we can work. Why this type of regression model we don't use generally in case of problem where we have sequence data, say time related data. Say suppose some participant has asked about the energy production or energy related data like on per day basis, or we can better correlate that same thing with the uh, real phenomena which happens in the stock market, because both data are on basis of real time only, and with respect to time they have a lot of meaning. So imagine if I take the screenshot of this so that I can better correlate why we do not take regression model for any data which is generally a sequence data or related to time, and show the reason. Paint, paint. Okay, put it here. Yeah. So imagine if I take a case, say white bar. Okay. So this is the line of observation. Okay. Now at a particular value of say stock, I want to know like what will be the outcome, say the next value. Okay. So here I have two cases. Mm, okay, the case one, which is this here, case two, this one part. Okay. So as a regression model, you have seen it is not accounting for the historical data or the past behavior. Okay. So you can assume maybe if you pass a value somewhere of the other feature which is correlating to the this case, okay, it can give you value either in up direction or either in down direction, right? In some bandwidth. Okay. But it in regression model, the reason of failure in case of time series data is that because do not account for the historical event. Okay, so that's why these prediction will be totally random in nature. But in case of LSTM, the advantage why LSTM is better over any time series based data is that LSTM not only take parameter or input as a kind of a single observation, rather a series of observation it asks you. Okay, so in this case it will take the entire set of these data. Okay, instead of one data it will take the historical data of say past 11 days or past 20 hour what was the phenomena, and based upon it it will decide whether the value can go in this direction or it can go in this direction. So that's why it predicts more better. So like in this case, it will give you more often in up direction only. And here, because the past event is fluctuating and more or less it is going in down direction, it will give you most of the time in down. Okay, if the point of observation and value are same only, but two results you will get in terms of regression model a different output, and in terms of LSTM model you will get a different output. But LSTM will be far more giving you better result. So that we will see it tomorrow, or no, not tomorrow, in last class, that is on Monday. So there we will be seeing it. So any doubt up to here? Regression model. I'll minimize this one first. I'll take a 5-minute break and then we will continue with the session. Okay, so now we'll continue. Any doubt up to here? Okay. So as we have created the model only, similarly we can create the function also. Yeah. So for function, we just have to click on the generate function, and inside that, like whatever we have taken feature into account, the entire code Matlab will going to create. So here, because the last one which we have selected as a kind, like the maximum temperature, minimum temperature, and sunshine, that is only true in the participation of the training model creation, and rest other feature are treated as false because we want to convert the last one as a kind of our trained model based upon the this feature. So it has only 3 out of 8. So Matlab 2 in function has taken that one into account and put true feature label for those predictors. Rest other predictors are treated as false. So this feature, this function has table as a kind of a data type, which will take as a parameter, and it will give you 2 output. One is the trained model output, and the other one is the efficiency in terms of RMSE. Okay. Now we will see toolbox also for deep learning. In Matlab, we have a toolbox also. We'll check that. So there's a deep network designer toolbox, which you can turn it on. So whatever thing we have did using command, we can do the same thing using this toolbox also. But as I told, like if you are writing the command, then it will give you more in-depth understanding of every step involved. Matlab is quite it's working slow. Okay, meanwhile, the participant can ask question if they have any. Okay, till then, what I will do, I will save the entire script into PDF and put it into WhatsApp. I don't know why it is taking a little bit longer time than unusual, but then also today's performance is good. Like till 4 o'clock, it worked very well. Save.
Excuse me, sir.
Yes, ma'am.
Sir, I have already asked you one question, like whether how come CCTV image that is in real time, how can that network will detect like that? He told me like
Okay.
the images that is captured from CCTV should be saved in separate folder like that.
Correct, ma'am. So for CCTV, you have to install some driver also,
okay.
like related to it, and then only Matlab can directly take images from CCTV, and you have to make sure that the CCTV image should go into a particular folder. So that folder address you have to integrate, and because it is a real-time photo, so you have to do it in this way also. Like you'll make one folder in which only one image, the real-time image will store. The next real-time image when it is coming, it will be overwritten. So you can, to solve this logic, you use the same name. Okay, like if you are saving the same file with same name, so again it will overwrite the file, right? So
Yes,
that
sir.
way, like when you will feed into any AlexNet based transfer learning or Google Net transfer learning, it will only see one image only, and as per that image, it will be giving you predictions.
Oh, okay, sir. Understood. Thank you.
So first in this file, I'll put it into WhatsApp group. So as for the topic, we have covered like whatever the topic was supposed to be covered today. So now I'll just show you one quick demonstration, like how we can use Toolbox also to create a deep learning model, and comparison of different nets, like what is in which case it could be better. So that demonstration I will show it here. Session optimization, image processing, Matlab session. No. Session 06, 13 June. Okay. File, save as session 06 with name session 06. 13. Okay, here it is. So this one file, put it on a WhatsApp group. Okay. Yeah. Yeah. So here is this network designer toolbox. So first I'll show the transfer learning category in order to correlate like what are the different model available in Matlab which you can import. And as I said, all these models are not the part of Matlab software, so you have to download it using like going to add-ons. Okay, it is external library in form of external library. It is there, so you have to download it separately. Okay, so this is related to the documentation of this model. Here I want to show a comparison which we have with different models. Where is that comparison? Transfer learning samples. There is a good graph which shows the comparison of all the AlexNet, GoogleNet, along this transfer learning. Not this one. I should have captured that image. I don't know why it is not showing here. Okay, let me check once again. Yeah, compared predictor network. Yeah, here is the graph. Okay, so relative prediction time using GPU. Okay, in terms of GPU, like how much time this network will take. Okay, and versus the accuracy. Okay, so they have like already tested this thing, and they have given a very nice documentation. So why we are using AlexNet? Because AlexNet is quite faster. It takes very less amount of time. Okay, and yes, the overall accuracy with respect to the other network, which is the latest version, is the NASNet underscore large. This is having the like better recognition capabilities compared to AlexNet, but the time taken by GPU is also higher compared to AlexNet. If you see, then here you have to make a good trade-off, like what model you are taking. Okay, because you have, if you are taking a very good model, then it will take quite high amount of time. So for GPU, like this analysis is there, but CPU it is not recommended, because in CPU it can happen like it can take half an hour just to open this NASNet underscore large model. Okay, and these are the total number of like in-depth layer present in all different models. So there they have a comparison, and what is the size requirement in each model. So in GoogleNet we have just worked 224, in AlexNet we have worked 227, and rest other are also in that range only. So for 229 by 229, which the participant have asked, for them also there is already an inbuilt model which is exception, with name of exception. They can download that model and directly train without resizing it into some smaller dimension. Okay. Yeah. So this was just the comparison of different networks with for the transfer learning model creation. Okay. So as you can see here, if you open the deep network designer, uh, it contains all the name of the presently used train model, but there you will see one triangular notch also. It says that, or it means that the model is not installed in Matlab, so you have to download and install it. Okay, so as we have like loaded this AlexNet already, so I can directly click on open, and it will take me to the designer app. So all the 25 layer of information will show here. And I can click on the first layer and see the property. Okay, like this is the name of this layer is data, and it contains the size of this. Similarly, the second layer, that is a convolution layer, so I can easily just, because it is UI, so I can easily give it a name. Okay, whatever I want, and can change the other values also. So it is just a kind of a graphical view which we are, or just a visual way we are just seeing it. Import data into network. So once we have designed the network, because in our case it is already pre-designed because we are using AlexNet. So next we will go to the data part, and data part we can click on the import, and we have to give the folder name, image data store in workspace, or we will better click on the browse file. So from there it can automatically take the data. Okay, so here it automatically take the data folder address, and here it asks you like if I want to split it into training data or not. So by default I keep it none. So here it gives a warning also that if I'm not using any testing, then it can lead to an overfitting problem. Just for this dummy experiment, I'm just showing this one, and then I can import it first. So now the data will be imported into the network. Okay, so here it shows a histogram. So because we have 7 images of cat and 7 images of dog, so the height of the histogram is same. And now we can go for the training model. So here it will first give you a training option setting where you can click, and like what we did in the code, the same option it will give it here to assign different values to all different terms. So what solver I want to take. So I have checked with SGDM. It is performing very worst in case of image recognition. So I'll take add a method. What will be the initial learning rate? And here the minimum batch size, I want to take 7 because already only 7 images are there, not as a whole. Maximum import by default is set to 30, and the other parameter I will keep it same. Just the initial learning rate, which is the important criteria, that one I'll like to check. So learn rate drop, learn rate schedule, piece noise, no, drop factor, drop period. Where is the learning rate? Okay, here it is only. So I can reduce this one. And now once the setting is done, then I can click on the training part. Invalid training data set, the output size is 1000. Okay, sorry, I have to make changes in the first layer only, in the third last, which is this layer. So instead of 1000, my output should connect to 2, not 1000. Create an output size. Uh, probabilistic output mean size fully connected layer. I'll take this layer information and remove this one. Select this line. Control. Okay. This one in between. And from here to here, I'll connect it. Oh no, yeah. I'll zoom it now. So here the size, the output size should be 2, not 1000. So that one I just deleted it, and rest all will be carried out with same sequence. And output size here also should be 2, not 1000. So this layer also I have to change it. So classification output I'll take, drag and drop here, and this one I'll delete, and instead of this I'll connect my layer. Okay. Fine. Now I'll analyze first. So it gives 0 warning and 0 error. It means my the network is perfect, and I can go for the training model. So now I'll click on here, train. Now the training has started, and it will take 60 iterations in order to give us the train model. Okay, and now we can export the model into form of a code or into just a mat file. So it gives message here that it has exported into a train network underscore one into the workspace. So here we have the trained model creation with layer information as same as AlexNet. Just the fully connected layer information will be 2. Rest everything is same. And now we can use this one, train infrastructure. So yeah. We'll check one thing, that is in layers, like what is the name of the classification. So this one will go and check in the classes. Yeah, it is cat and dog. So it has trained on our model. And with the same process, you can do the testing also. So we have covered up the session for today. Any doubt from participants? Now we'll take the doubt session only. Beside accuracy, you can, in case of regression model, you can check for the spread of the residual error. That also can be very effective.
Sir, excuse me. Sir, for CNN, Sir, for CNN, only that
Okay.
accuracy is sufficient. We need to check other parameter like AUC or some other parameter.
Sir, actually, this CNN is meant for is a kind of a deep learning model. So yeah, the performance you can check with the accuracy and loss only, but you have to do the afterward test also. Like whatever accuracy it gives, say in our case, whatever we have taken the 2 simple example, each time the accuracy will end up into 100% only. But we have seen, like when we do the testing on entirely random data set, there it is not performing like to 100%. It has like only 66% efficiency, or say 75% efficiency. So with the help of accuracy, you just can be like little bit confident, okay, like how much that the model has trained. Okay, but for the real accuracy, you have to better test it on a different kind of a large test data set. Okay, so suppose you have thousands of images, then at least 100 of image you keep it separately, which won't enter into the training model. Okay, and once the model is created, you test on that 100, like what is the performance, and based upon that performance, you can get a better accuracy, because it is a kind of a like neural fitting first it is doing, okay, as per the given images. So there can be chances that it can overfit or it can underfit. So that we will come to know only after testing on a sufficiently good uh, untrained data set. I hope the doubt is clear, sir.
Sir, another thing, many people draw that AUC curve. So AUC curve, here is there a chance to draw that in CNN? In Python, do that AUC curve.
AUC curve, 1 minute. What is that AUC curve?
ROC, AUC, ROC.
ROC, okay, okay,
ROC.
correct, correct. Mm,
Sir,
yes, ma'am.
sir, can you please show the regression model once again? I got disconnected due to network issue. Like the first part of the regression model, like what we
From
were
the
doing.
beginning, you are asking ma'am to show like how we can run the regression model.
Yeah, the last part I could see, but the first part I missed it.
Okay, okay, fine, fine. I'll show it once again. Hmm.
Thank
Hmm. So first, what we did, we imported the data using data import toolbox, and here we have selected this data, which is called weather data. Okay. Inside weather data, we have so many data related to other things also, but we want to know like which feature are dominating in nature, which decides the temperature at 3 p.m. So the data is being loaded, you will read. So here we have data in which the ninth row is empty matrix, empty row. So that one also we have to eliminate before feeding it for the training purpose. So here our target is, or our objective is, that we want to predict temperature at 3 p.m. on the basis of minimum temperature of that day, maximum temperature of that day, sunshine period on that day. Okay, and similarly, whatever we think can be the uh, predictors in this regard. So after importing the data, it is up to us like which column we select. So in this case, we have selected minimum temperature, maximum temperature, sunshine, wind gust, and humidity at 9, 3 p.m. And say I'm taking temperature at 9 p.m. So based upon these data, I want to predict temperature at 3 p.m. So after this, I'll import this data using import command, and the data is stored into workspace in a weather variable. So now I'll take a different live script, open, no, new live script. Yeah, so here I'll first show like how the weather data look like. Weather, and I'll run this command. Okay, so we have total 8 number of columns. So out of this 8 number of column, we have 7 features, and the 8th one is the response or the output. Now, before feeding it into a deep machine learning model, we first have to remove this part, which is an empty row. Okay, so this we can easily do using the is missing function, and we can remove it. So for that, I just select this Matlab feature in order to generate that simple code for me automatically. So I'll just uncheck this is missing, and it will write the code, and this code I will click on update code, so that code will be updated into the live script. Okay, and now if I run the command, now that ninth row, which is empty matrix above, you can see now I don't have any empty matrix, so it cleaned the data, and now I can go for a regression learning model. So I'll first close this model and open it once again. Okay, so I'll go in app section, and in machine learning and deep learning toolbox, I will click this regression toolbox. Now, once this toolbox is loaded, I'll click on a new session and load data from workspace. And I know that my data is into weather data set. So here it will automatically load all the predictors, and my response is in temperature 3 p.m. as the output. So that one is automatically loaded here. And say suppose I take 4 by 5th of the data of the entire table as for the training, and 1 by 5th will be kept for the validation purpose. So keeping this setting as it is, I'll start my session. Okay. So here in the scatter plot also, I can get some correlation, like which feature will having a good impact on the overall this thing, like prediction of the response, because the scatter plot gives a plot between the predictor versus the response. Okay, so if we have a kind of a uniformity in that, like in this case also we can see it is like an uptrend only. If I take maximum temperature, then maximum temperature is too close, making a 45-degree slope, so it is like close to 1 in correlation factor. Sunshine, if I plot, then sunshine is too much scattered data, so on sunshine it doesn't depend. Wind gust also is too much scattered. Humidity is negatively like correlated, so it means it has a good impact over predicting. And temperature at 9 also has a good correlation. Okay, so here in the feature selection, I can check only those feature which can have a good correlation. Okay, so say suppose for this example, I take all feature, and then I would like to correlate after seeing the residual plot and all these things. So because in initially I don't know which of these model, like regression model and all this coarse tree, medium tree, or SVM, quadratic, cubic, or rational quadratic or boosted tree, which method will work best, okay, or KNN. So what I will do, I'll click on all, and I will run this model in order to give me the best model which can be very effective in this case. So it will start a parallel pool. If like in your system, if it has GPU, then it will turn the GPU on, or if you have like more than i3, i5, i7 like that, so it will start a parallel processing for this problem. it will take 1 more minute time in order to open the parallel processing part, and then we can see the model being trained. Okay, now we can see the parallel pool has started. Okay, so now we will go to the machine learning model. Actually, in second half, my system little bit gets slow down. So yeah, now it has started. So we can see like Matlab is loading all the different types of machine learning model, and it will start testing also on each. So here 7 by 7 means out of the all 7 feature, it is taking all 7 feature into consideration, and based upon it, it will give the training model. So anytime we can reject some feature also, and we can see like what is the overall improvement in the result or not. So here our target will be to select that model which has the least RMSE value. Okay, so it gives SVM quadratic. No, not SVM quadratic. 1 minute. Yeah. So here this time it gives a better result with Gaussian process regression, because earlier we have taken 8 features and now we have taken 7 features. So in this 7 feature, maybe one feature will be quite different with respect to the in the previous case which we have taken. So this is giving the best result, which is Gaussian process regression. Okay. So once we get this model, if you want to see the impact like after what happened. Okay, all of a sudden it becomes unresponsive. Okay, fine. Maybe some background work is working. Okay, yeah. So say suppose now I want to test it. What if what will the performance of the machine model if I remove some features, say humidity at 9 I want to remove, and wind gust speed I want to remove it, and based upon the rest 5 how the system will perform. Okay, so we'll select this model which is Gaussian process, okay, which is rational quadratic. Okay, so this one, and I will run on this and see the performance. So it can give a better result with this, so that too also we have to check. Now we will select this one and see the residual plot in order to get an idea like which model is performing better in terms of seeing its spread of error. So this is the earlier one where we have included all the 7 features, and now we'll select the second one and try to see like what is the spread. Okay, so here we are getting almost the same spread, almost it is same. So we'll go for this model only, like Gaussian process regression model. And here for export we have again 2 options. Either we can export as a final model in which we have to just pass the input table and it will give us the output, or we can generate an automated code for it using generate function command. Okay, so it depends upon us like what we want. We want a function or a just a trained model. So here I clicked say for the generate function, and here Matlab writes an algorithm also for me, like what I have to write in order to first start the training on that model, and then it will give me 2 output. One is the trained model and the other one is the value of the RMSC. Okay, so this way you can then directly use it, maybe which we have already seen here. Or I think in command prompt only we have checked it, like here. So that is the name of the model, and after that, like after writing the model name, we have to use a predict function and pass the test table, and that table will contain all the predictors value excluding the response, and it will give you the prediction of the temperature. Okay, so here we have passed one value set in which minimum temperature was 12, maximum temperature was 29, and so does the other value, and it predicted that in this case the temperature at 3 p.m. can go up to 27.66, like this.
Okay, sir. Got it, sir.
Okay, sir, minimum number of data required to develop a regression model. Minimum number of data required to develop a regression model. There is no such thing as like how much should be minimum and maximum, but as we know from the theory that machine learning is entirely based upon the experience. Okay, so if you give more amount of data, more better the machine learning model will be. So from our end we should try to give as much data as possible.
So actually, I have downloaded some data from the satellite map,
Okay,
which is regarding the LULC, land use land cover map.
okay,
And I need to develop a model so it should be how much it is predictive for the future. Like I have downloaded from 1999, and then at every 5 years gap, I have downloaded the map.
okay,
Uh,
okay,
so and it is not possible to get as many data as possible. So I've downloaded
correct,
only
correct.
3 to 4 data. So,
Okay,
and I would like to predict the that factor for for the future period.
okay. So here, because your data is related with time also, right?
Yes, yes, sir.
Correct. So here also like LSTM will be like more effective. In any case, if you have a
Yes, sir.
time related data, better
Yes, sir.
go for LSTM in case of future prediction.
Hello, sir. Yes, sir.
Yes, sir.
Okay, sir.
Um,
Sir,
sir,
one.
okay.
Yes, ma'am.
Carry on, carry on.
No, you can carry on. It's regarding the same
Sir,
idea.
I'm having a doubt regarding my project work. That's what I'm
Okay.
saying. Sir, I've mailed you as well. The data of soil erosion, I have calculated the soil erosion map
Mm-hmm.
for the year 2019, and I would like to the map has come pixel wise in ArcGIS, sir, and
Mm-hmm.
every pixel is having a different soil erosion value,
Okay.
and that soil erosion map, I need to relate it with the slope of that
Okay.
topographical, and
Okay.
one more map I am having, that is topography map, and each
Mm-hmm.
pixel will give you the different slope value, that is in
Okay.
degree only.
Okay.
So I want to relate these two data, sir. That means at every pixel of soil slope, how much it
Mm-hmm.
will be the soil erosion at every pixel, sir.
Okay. So these two data, but you already have, right?
Yes, sir. I'm having those data.
Okay. So here you want to do some mapping, like you want to make a separate table
Yes, sir.
keeping all these XY coordinates, right?
Sir. Yes, sir.
Okay, okay. Yeah, that is possible. Okay, for that I need to have the data. Then I can
Yes, sir.
tell you like which algorithm you can use
Sir,
to transfer.
one how to import those data into that Matlab? I'm not getting the. I mailed you, sir. In the TXT form, it is coming. Like I need to
Yeah,
convert
yeah.
it into the,
I have
yes,
checked your
TXT form.
mail, but I
Yes,
haven't
sir.
accessed the data. So what I
Okay,
will
sir.
do on Sunday, I'll try to access it and
Yes.
put it into Matlab and see
Uh,
like in what
okay, sir.
way we can import the
Okay,
data into Matlab
sir.
because I'm not getting time.
Is okay, sir. Sir, is there any meaning of it is some of the data are coming like a minus nine, minus 9999? What does it mean? It it is showing something like no data value minus in TXT form it is coming like minus 9999. What does it mean, sir?
Uh, Generally, they should not give, but as you're saying, let me check. Maybe
Okay,
there can be some outbound error. So let me
yes,
check
yes.
also. Like how many times 9 is there? Four
mean
times or 5 times?
means it is like uncountable, sir, like it's
Oh,
so
ho,
much,
ho, ho. Okay, okay.
minus double nine
Okay,
double
got
nine,
it,
sir.
got it. Yeah, it is
And
outbound error only.
some values, it's showing some values as well, like some values are there also. If you scroll
Okay.
down and write to the txt form, sir, it will show some
Okay.
values as well.
Okay, in that case now, try to
So,
import that thing into Sublime Text Editor. That is hardly, I
okay, sir.
guess, 9 MB software, but
Yes,
it is
sir.
very good in dealing with like different data types.
Yes, sir. Okay,
Okay,
sir.
it is this
Okay.
software you can
Yes,
try
sir. Yes, sir.
Sublime Text Editor.
So I put it on the drive where you may access, and I'll give the
Sure, sure,
permissions.
sure, sure. I'll have a look. So this software
Okay,
you
sir.
can download it and give it a try because this
Sublime
is very
text.
good
Okay, sir.
software
Okay, sir.
for developers. Yeah.
Okay, sir. Thank you, sir. Thank
Uh,
you very much.
Oh, thank you. Yeah.
so my question is was that the since we are using time series data, there are
Correct, ma'am.
models like large models, like in financial time series we use these models.
Correct, ma'am.
So
Correct.
these are also regression based models like
Correct,
VCM,
correct.
where these are so like how is it different from the ones we are using here? I mean, obviously we are using SVM and ANNs and Gaussian distributions. So
Okay.
is there a way to compare those two? I mean, I thought that in the regression only we'll have multiple ARIMA guards, these type of models as well.
Ma'am, actually, all this method now, like as I have taken this example, okay, like wait a minute, I'll check whether impede I have or not. Yeah, 1 minute, I'll show it once again. Okay, like I have discussed the limitation of why this regression model can sometimes fail. Okay, like as per
Yeah.
this data, say the stock market
Yes,
data,
sir.
the stock market can have the same value in a different number of days, right? Like say suppose today
Yeah.
Monday, it can have the same value, and on Thursday also it can have the same value, on Sunday also it can have the same value. The repeatability is quite high because of the fluctuation, right? So in that case, if
Hmm.
you opt for a regression model, then because this regression model do not account for the historical event, like what occurred in consequence. Like say suppose if you consider this case, then here, if there is any model which consider the past effect also, like what was the past behavior, if in the last 2 3 days, if it is rising, then there is high probability that at this point it will still even go higher. Okay, so these types of consideration are effectively considered in LSTM. That's why it is called long short term memory, because there you pass
Yes.
the data in terms of past sequence also. So say suppose a climate change is there. So climate change do not happen absolutely randomly. Rather, it carries with some sequence. First, the temperature will go down. Okay, then there will be some high wind velocity. So all these phenomena occur one after another. Okay, so that way it becomes a lot easier if any machine learning model is there which accumulate all these phenomena into particular sequence and then predict, then it is best. Okay, but in case of regression we are passing only one value, like say here only and here. So as I discussed here we have two cases. The regression model can give randomly either down or either up. But if you use LSTM, then LSTM will always give you higher in this case, and at the same value, if you pass this one, it will give you lower here. Why? Because it will also take data from the historical sequence also from your side. Okay. So there,
Sir,
instead of
so
one value, you pass up entire sequence of data, like last sequence of 30 days, and then it will predict the 31st day output. Okay. So like that way LSTM works.
so sir, like the models like ARMA, ARIMA, they are also considering past data because they're having moving averages and auto-regressive terms in their models.
Now,
So
moving average is a this thing feature. Okay, like what I'm saying here in LSTM, what happens? Say, suppose I want to predict at 29th day, and my LSTM is trained on 10 data sequence. So, for the prediction of 30 days, I have to give from 19 to 29 as a complete set of all feature also. Like what was the stock value at this? What was the moving average? So entire complete data set I have to provide it. Then only it's going to predict the 30th day output.
so this I understood, but what
Okay.
I am saying is that my time series modeling,
Mm-hmm.
they also consider the past data.
Correct,
It's
correct.
not just.
So yeah, correct. Fine. So what problem you are getting there?
So the argument you are giving is that my regression model won't consider the past data, and it will only predict based on a value, right?
No, actually, the regression model which we discussed right now, which do not contain any this information like related to past event, for in comparison to this regression model, yes, this will be
Okay,
ineffective compared to the LSTM version.
okay. So even the all the trees, decision trees, and the all the processes which are listed here, they will be ineffective.
For the
You are
time series
saying?
data, yes.
Okay,
and
okay.
and why it will be ineffective, like once I will start tomorrow session, like on Monday, you will automatically come to understand like how and why LSTM is more better compared to all this regression model only in terms of data which are having time series relationship. Okay.
Okay, okay, got it.
Okay. So we will end our session here, and we'll start the last session from Monday onward. Okay,
Excuse
thank
me,
you,
sir.
participants.
Sir,
Yes, ma'am.
excuse me, sir. Sir, I had mailed you yesterday about the Excel sheet with the Matlab.
Okay, 1 minute, ma'am. Let me check.
Yes.
Because what happens now, I'm not getting enough time to even check my WhatsApp and Gmail also sometime. I'll check it
So you
now.
have replied me also. That
Uh,
Vaishali Kulkarni.